So just like when we started, as an example, when we started looking at systems of equations, the first thing we did was we looked at solving systems by graphing. And what that allowed us to do is get a good visual of where the solution was. And the same kind of thing is happening with our graphing calculator when we solve a quadratic, because we spent a lot of time graphing. And we spent all last week working on that. And the truth is that's part of why we did it. But the other part of why we did it is to find the solutions to quadratics. And this picture here is in your book on page 552. So either, screenshot it from your book or take a picture of the screen. But there are three different scenarios that we could have with quadratics and their solutions. And so go ahead and get that in your notes, and then I'll go through this all and talk about what it all means. Now, there are three different scenarios here. Okay? And I'm going to point something particularly out. There we go. We could either have one real solution, two real solutions, or no real solutions when we talk about quadratics. Okay. Later on in chapter 4, after we get back from break, we'll talk about imaginary numbers and complex solutions. And this one's going to have complex solutions, imaginary number solutions. Okay, and we'll talk about that more after we get back. But if you notice here, the vertex of this parabola it lies on the x-axis. So there's one place where this parabola touches the x-axis, and therefore there is one real solution. This parabola actually crosses the x-axis in two different places. Therefore, it has two real solutions. And then like this one doesn't touch the x-axis at all or cross it, so that's why there are no real solutions. The point is the solutions can be found at the x-intercepts of the quadratic function, of the quadratic graph. We've spent a lot of time talking about y-intercepts. And the truth is, y-intercepts are just points on a graph. X-intercepts really have more meaning and are more important to us. And we're going to spend more and more time talking about x-intercepts because those are where you can find the solutions. Now, there's some other terminology that will be used throughout the course of this chapter and throughout the course of math. So they can be called solutions. That's one thing that they can be called. They can also be called zeros, and sometimes they're called roots. They all mean the exact same thing and could be used interchangeably. So if they're asking you for the roots of a particular equation, they are asking for the solutions. If they're asking for the zeros, they are asking for the solutions. If they ask you for the solutions, they are also asking for the roots. Any of these words can be replaced with the other, and they mean the exact same thing. What I want from you is to understand that it's always just asking the same thing in a different way. And sometimes the context has something to do with it. I don't expect you to recognize that context necessarily, but what I do expect is that you understand that this, and this are all the same thing. So let's get to actually using calculators and doing some graphing. So here's one kind of problem you're going to get. Solve the equation by graphing. Now, one of the things I will tell you, some of the problems that you're going to have for homework will already give you the graph. So you don't really have to do anything except state the solutions. But in other problems, it's not. And you're going to have to actually do the graphing. And I'm going to show you how to do that in your calculator today. Now, if you've already played with your calculator, you've done some graphing on it, maybe this won't be new to you. But I think for a lot of you, it's going to be brand new. Okay. The first thing we have to do when we want to graph something is we have to make one side of the equation equal 0. Okay, that always has to happen. Throughout chapter 4, we're going to keep doing that over and over and over again, except in one case that, again, we'll talk about after the first of the year. One tip I would like to give you is leave the x squared on the side that it's on. Okay, move everything to the x squared side. That's the best tip I can give you. Okay. which means which number has to move?
The 12.
Be more specific.
Negative
12. Thank you. So how am I gonna move this negative 12?
Add it.
Add it to both sides. So go ahead and do that and make one side equal to 0. And then check green and see if you got the same thing as me. All right, so our next move is to enter this in the calculator. And before we can enter it in the calculator, what we do is we have to think about this equation differently. Okay, so instead of it being 0, we're going to think about that 0 as y. And we're going to enter this in. And I'm going to walk you through how to enter this in and where you need to go to do that. So for those of you who this is new to, I might be going slow for those of you who have done this before. But I'm going to go slow because I want to make sure that everybody is on the same page. So here's your calculator, or something close to your calculator. Okay, pretty much looks like that if you have a TI. If you have a Casio, then you might need to see me outside of class for some extra help or figure it out for yourself. But if you have a TI, it's pretty much going to look like this. Even if you have an older model, the buttons are all in the same place. Okay, so
It's got the periodic table on it.
here's where we're going to live. Okay, when we graph, we live in the y equals screen. So the y equals button is top left. Y equals is top left. So hit that button, and you should get to the y equals screen. There's a couple things I need to warn you about on this screen. First off, at the very top, you see the word plot 1, plot 2, plot 3, etc. Okay? If any of those are highlighted, that's going to be a problem. Okay? So if any of those are highlighted for you, go up and just arrow up to it and hit enter on the one that's highlighted, and you will toggle it off. The reason those plots exist, we use that in my statistics class. If you want to graph a scatter plot, if you want to graph a histogram, if you want to graph a box plot, all of those things can be done on this calculator. And so that's what the plots are for. So if you have a plot turned on and one of those words plot is highlighted, it could create a problem for you when you graph. It won't let you graph. So make sure that those are turned off. The second thing that you need to do is scroll down the y equals. Make sure there's nothing in there. Every once in a while, someone will hit a button at the very end, because it goes down to, I think, 10 equations. You don't see them all on the screen. You want to scroll all the way down and make sure there's nothing in any of the other equations, because that could create a different type of graph, and it might give you an error too. All right. Now, when we enter this in, this button next to the green alpha key, where it says xt theta n, that's where our x is going to come from. So when we go to enter this x, you're pressing this xt theta n button next to the green alpha key. That's where your x is going to come from. Now, to put the squared on, you can do one of two things. You can hit the x squared button, or you can hit, this is called a caret, and it will basically give you a superscript so that you can enter the power of 2. This will come in handy later when we're using equations that are higher than the second power. But either way, hit x, then x squared, or x caret 2. Either one works. And then this, be careful here, this is a minus. Our calculator makes a distinction between negatives and subtraction signs. So in this case, this is a subtraction sign. Do not use the negative, use the subtraction sign. If you use the negative, it's going to give you something, x to the third. It's going to multiply them together. Or it could give you an error. Okay? And obviously plus 12. All right? Raise your hand if you're having trouble entering. Okay, so what you should get is a screen that looks like this. Okay? Now, notice again, all my plots are turned off. None of them are highlighted. You enter it all into Y1. Obviously, yours may look a little different if you have a newer one than the one I used for this video, or for this
Demonstration.
slideshow, whatever you want to call it. Okay? But same idea. Okay? It should all be in there. Anybody still having issues? Okay? Next, what you have to do is hit the graph button. Hit graph right here. It's top right. Hit graph and it'll graph. Now, if you don't get the graph, raise your hand and I'll come around and fix it for you. So here's what you should have gotten. Let's see. Notice right here, right above the graph button, the word table. So if you hit second graph, you're going to get a table that is associated is a graph like this. Now, sometimes what will happen is, and I'm going to show you how to do this in a minute. Sometimes you'll zoom in on stuff, zoom out on stuff, move the graph to a different place, okay? What you're looking at here is the standard window. This is a 10 by 10 window, meaning this is positive 10 to the x, negative 10 on the x, positive 10 on the y, negative 10. Okay, and we were just working on that over there. Brady's was zoomed in. And when you want to get back to this window, the easiest way to do that is to hit the zoom button and then number 6. And you can literally press zoom and the number 6 button. And it will take you back to the screen and it will graph it again. Okay, zoom 6 is when you get lost and your graph is zoomed in too far or zoomed out too far, hit zoom 6 and it'll take you back to the standard 10 by 10 window. Okay? We're going to get to that in a minute. We're going to talk about zooming in here in a minute. Okay? Now, let's talk about the solution. So, one of the things that you're going to have to do is, I'm not going to make you graph these by hand. So, if this was your problem in the homework, what you would do is you would take a picture of this screen and you would insert it into your homework. Okay, I'm not going to make you sketch it by hand or graph it by hand. Okay, I want you to take a picture of that, put it into your homework. Now, we have to solve it. We haven't solved anything yet. All we've done is graphed it. Now, if you think back to the first slide I showed you, or second slide, I said we have to look toward the x-intercepts to find the solutions. Okay, so I'm going to zoom in on this picture and see if we can figure out what the x-intercepts are. Okay. So we're looking for where the graph crosses the x-axis. What do we think the solution is here? 2. What do we think the solution is here? 6. So 1, 2, 3, 4, 5, 6. So what we would say is that x equals 2 and 6. Or you could say, you could write it like this: x equals 2, comma 6. Or you could say x equals 2 and x equals, I don't care. All those things are the same thing. Okay? Give me either this or this or this. One of those is fine. Okay? One thing I do want to point out though, the solution is not the actual x-intercept. Because if I was listing the x-intercept, I would say 2, 0 and 6, 0. That's not what we say for solutions. It's just the value that x is. Okay? And again, in your homework, in some of the problems, they're going to give you the graph and they're going to say, what's the solution? And all you got to do is pick off the x-intercepts and those x values and you're good to go. Okay? There's going to be another type of problem that you're going to work on too. Okay? Are there any questions before we work on the next kind of problem? Yes? I forgot about this. Oh, you're going to be mad at me. Yep. So, if we wanted to verify, okay, maybe we're confident that this one is 2, 0. Maybe we weren't so confident about this one. If you want to verify it, okay. Oh, wait, before we do that. With whatever equation you have listed in Y1. So if you hit second graph, which will get you the table, notice here, the calculator will generate a table of values for whatever you've entered into the y equals screen. So if I had something in y2, it would give me those y values too. But you can scroll up and down. Play with that a little bit, okay? Scroll up and down and find, you can see all those other points. So again, in order to access the table, you have to hit second and then the graph button. The table will only give you something if there's an equation in the y equals screen. Now, this verifies for us that 2 is a solution because the 2, 0, that's where the x-intercept is. So one of my solutions is 2. My other one is 6. And the table verifies that for us because 6, 0 is an x-intercept. 2, 0 is an x-intercept. These are my solutions. So you can use that table to verify those values, okay? Now, in the next kind of problem, the table is not going to really be any good for you because sometimes our graphs don't exactly go through an integer. And that's what a problem like this is. Okay, so go ahead and get that in your notes. And then we'll talk a little bit more about what this equation means. All right, so in these directions it says, if exact roots cannot be found, state the consecutive integers between which the roots are located. So if it's not an exact value, we're not going to try to figure out with our graphing calculator what the solution is because it's going to be an approximation. So instead what we're going to do is we're going to stay in between 7 and 8, in between -1 and -2 or something like that, okay? But we start the same way. So go ahead and enter this equation into your y equals screen. Get rid of the old one, okay? Get rid of the old equation. And even if you have one of the newer ones where each equation is a different color, just go ahead and clear out what you had in y1 and replace it with this. And then graph it. And take a look at the screen. Make sure you got the same graph as me. You should have. Now, here's the thing. I'm pretty confident when I look at this that this particular solution over here is in between 0 and 1. Okay? I'm not so confident with this one because it looks like it might actually hit 5. This is 1, 2, 3, 4, 5. I'm not sure. So what would be nice is if we could zoom in on this spot, which is what we're going to do next. Okay? So let me, first off, like I said, I'm confident about the first one. So one thing to keep in mind is I have my 2 solution areas where the x-intercepts are. This one is definitely between 0 and 1. I'm confident with that one. It's definitely missing 1. And so that's how you express it. When it says state the consecutive integers between which the roots are located, that's what you say. Okay? This one I want to get a closer look at. So what we're going to do is zoom in on it. Okay?
Can you write it like that or no? As a solution?
I would prefer that you don't.
Okay.
Okay? So here's what you're going to do. So hit the zoom button, which is top middle, and number 2 is zoom in. Now, when you hit number 2, nothing is going to happen. So hit the arrows, you'll see a little cursor. Move the little cursor over to here somewhere. And once you're in this area, then hit enter, and it will zoom in on that particular spot. Okay? And so because we are now convinced that this does not go through 5. So the other solution is in between 5 and 6. If you wanted to look at the table, you could. And what you would notice is that there is no y that equals 0. Which is because there's no integer x value that will result in an x-intercept that allows y to equal 0. Okay? So these are your 2 different kinds of problems. In any case where they're asking you to solve by graphing, if they don't provide the graph to you, you're going to enter it in your calculator and you're going to take a picture of that screen like this and put it in your homework. Okay? Questions about any of that? What you'll end up with is something like this. And if you notice, at the bottom of the screen, you will see coordinates. And those are the coordinates of the cursor. It is not important. It is not important to figure out what the x value is, because there's no way currently to verify that I'm on the line. Okay? It's giving me a ballpark. But what it is telling me for sure is it doesn't go through 5. It misses 5. This is 5 here. This is 6. So what it's doing is we're verifying that it is not an exact value. Okay? The only way to ensure that you're on the line is to actually use the trace button, which is next to the graph button. And there's no guarantee, because the trace button will jump up and down on this thing. There's no guarantee that it'll hit there either. So that's not the point anyway. Our point of zooming in is just to verify that it does not, in fact, go through an integer, which we've done. Now, to take your calculator in the graph window back to the standard window, what do you press?
Zoom 6.
Zoom 6. Very good. Hit Zoom 6 and it'll take you back. Okay? And now we can finish up this problem.